Welcome to our channel, Curious Minds Area. Today, let's embark on a fascinating journey through the evolution of space station concepts. We'll delve into visionary ideas dating back to Johannes Kepler in the early 1600s and trace the developments made by both the United States and the Soviet Union in the 1960s. Join us as we uncover the captivating history of space exploration and innovation. Johannes Kepler, a renowned astronomer of the Renaissance era, envisioned a future where humans would traverse the cosmos. He was the first to grasp the concept of planets as habitable worlds and the notion of space travel. Edward Hale's Brick Moon, featured in the Atlantic Weekly magazine, depicted a space station orbiting Earth. This man-made structure not only housed crew members but also served as a navigational aid for Earthlings. Konstantin Tsiolkovsky, a Russian theoretician, contemplated designs for space stations leveraging solar power. He envisioned these stations as self-sustaining habitats capable of fostering vegetation within their confines. Hermann Nordung laid out detailed engineering and construction plans for a space station in his work. He proposed a rotating wheel-shaped station, emphasizing the necessity of rotation to simulate gravity for crew members. Willy Lee vividly described life within a wheel-shaped space station, likening it to existence aboard a modern submarine. His portrayal, featured in publications and media, captured the public imagination, portraying space stations as self-contained communities meeting all human needs. In the 1950s, the US government, particularly through initiatives like the US Army Project Horizon and later NASA's Manned Spacecraft Center, delved into space station designs. Patented concepts and developments laid the groundwork for future endeavors such as Skylab. Simultaneously, the Soviet Union pursued ambitious plans, including a super rocket launcher and the large space station projects. Despite setbacks like unsuccessful test launches, they pivoted towards smaller stations like those launched by the Proton rocket. Let's dive into the fascinating origins and execution of the International Space Station, ISS, during its early years. In 1984, the approval of the space station by President Reagan and the subsequent budget approval by the US Congress marked the beginning of an ambitious era in space exploration. NASA Administrator James Beggs wasted no time in seeking international partners to collaborate on this groundbreaking project. Soon after, countries such as Canada, Japan, and numerous nations within the European Space Agency eagerly joined the endeavor. Over the next 9 years, from 1984 to 1993, the space station underwent meticulous design phases. Construction of various elements commenced across multiple continents, including the United States, Canada, Japan, and Europe, signaling a truly global effort in the pursuit of space exploration. In 1993, amid ongoing redesign efforts, an invitation extended to the Russians marked a significant turning point. An agreement was reached to proceed in 2 distinct phases. Phase 1 saw NASA space shuttles ferrying astronauts and cosmonauts to the Russian Mir orbital station. During this phase, the United States played a crucial role in modifying 2 Russian-built modules to accommodate experiments from both US and international scientists, while also fostering collaboration between participating nations. Phase 2, led jointly by the United States and Russia, envisioned a grander undertaking, the creation of a new International Space Station, ISS. All participating nations would contribute elements and crew members to this monumental project, solidifying the space station's status as a symbol of global cooperation and human ingenuity in the exploration of space. The ISS is a testament to international teamwork, with components built in countries worldwide. Like assembling a giant puzzle in space, each piece was meticulously launched and connected using advanced robotics and astronaut expertise. As the largest human-made structure orbiting Earth, the ISS boasts impressive figures. With a pressurized volume of around 900 cubic meters and a mass exceeding 400,000 kilograms, It stands as a symbol of human achievement in space exploration. Powered by expansive solar arrays covering 2,247 square meters, the ISS generates 735,000 kWh of electrical power annually. This sustainable energy source ensures the station's continuous operation as it orbits Earth. Positioned at an altitude of 370-460 kilometers, the ISS orbits Earth, facing challenges such as atmospheric friction. Regular rocket firings are required to maintain its orbit, with an inclination of 51.6 degrees, enabling it to cover over 90% of inhabited Earth. Hosting a crew of up to 13 members, the ISS serves as a permanent habitat for scientific research and international cooperation. Supported by various vehicles like the Space Shuttle, Russian Progress, and commercial spacecraft, it receives vital supplies and crew exchanges to sustain its mission. The assembly of the ISS wouldn't have been possible without the extraordinary efforts of spacewalking astronauts and cosmonauts. These extravehicular activities have been conducted not only in Earth's orbit, but also on the Moon's surface, and in the vast expanse between Earth and Moon during prior space programs. The cumulative experience of extravehicular activities before the start of the ISS program laid a solid foundation for the challenging spacewalking tasks ahead. However, during the ISS program, more spacewalks have been conducted than in all previous programs combined, showcasing a remarkable leap in human spacewalking capabilities. From the inaugural ISS extravehicular activities conducted by astronauts Jerry L. Ross and James H. Newman in 1988 to significant milestones like the first US-Russian extravehicular activities, the ISS assembly missions have been marked by historic achievements and groundbreaking feats of human exploration. International partners have played a vital role in the ISS assembly, with astronauts from various countries contributing to spacewalking endeavors. From the first Canadian and European spacewalkers to astronauts from Japan and beyond, the ISS embodies the spirit of global cooperation in space exploration. Despite facing challenges like reduced crew sizes and technical complications, spacewalks continue to be a cornerstone of ISS operations. The return-to-flight missions, the first spacewalks by astronauts from Japan and the European Space Agency, and the innovative repairs conducted during extravehicular activities underscore the resilience and adaptability of the ISS program. Experiments conducted at the International Space Station cover a wide range of scientific disciplines, offering valuable insights into the effects of microgravity on biological, physical, and technological systems. Number 1. Plant growth experiments. Various experiments have been conducted aboard the International Space Station, ISS, to study plant growth in microgravity. These experiments aim to understand how plants adapt to the space environment and how their growth patterns differ from those on Earth. Researchers investigate factors such as nutrient uptake, root development, and flowering in microgravity conditions. Number 2. Material science experiments. The ISS serves as a unique laboratory for conducting experiments on material science in microgravity. Researchers study the behavior of fluids, metals, crystals, and other materials in the absence of gravity to gain insights into their properties and behavior. These experiments have applications in various fields, including manufacturing, electronics, and medicine. Number 3. Human physiology experiments. Numerous experiments focus on understanding the effects of long-duration spaceflight on the human body. These studies investigate changes in bone density, muscle mass, cardiovascular function, immune response, and other physiological parameters. Researchers aim to develop countermeasures to mitigate the negative effects of spaceflight on astronauts' health and well-being. Number 4. Astrophysics and Earth observation. The ISS also hosts experiments aimed at studying astrophysical phenomena and observing Earth from space. Instruments on board the station enable researchers to conduct experiments in fields such as cosmic ray detection, particle physics, and Earth observation. These experiments contribute to our understanding of the universe and help monitor environmental changes on Earth. These are just a few examples of the diverse range of experiments conducted aboard the International Space Station, highlighting its role as a premier research facility for advancing scientific knowledge and enabling human exploration beyond Earth. Because the International Space Station, ISS, moves really fast around Earth, time there goes a tiny bit faster than it does here on Earth. So, astronauts on the ISS age just a tiny bit less than people on Earth do when they're up there for a long time. In 2015, the ISS received a specially designed espresso machine, allowing astronauts to enjoy freshly brewed coffee in space for the first time. The machine, named Espresso, was developed in collaboration with the Italian Space Agency and Lavazza. In 2020, the ISS hosted the first ever Space Olympics, where astronauts competed in various physical and mental challenges to showcase human performance in microgravity. This event highlighted the camaraderie and spirit of exploration aboard the space station. The ISS generates oxygen through electrolysis, splitting water molecules into hydrogen and oxygen using electricity generated by its solar panels. This process ensures a sustainable supply of breathable air for the crew. As we conclude our journey through the wonders of the International Space Station, we're reminded of the remarkable achievements and discoveries made possible by human ingenuity and international collaboration. From groundbreaking scientific research to fostering a spirit of exploration and unity among nations, the ISS continues to inspire and captivate us with its enduring legacy in space. Thank you for joining us on this extraordinary adventure. If you enjoyed our content, don't forget to like, subscribe, and hit the notification bell to stay updated on future videos. Until next time, keep reaching for the stars.